Hello Year 6. Today's maths is comparing and ordering decimals. So the support task that I put together today is taking it back to look at whole numbers and how do we compare and order whole numbers, just to jog your memory on that one. And I think once you've had a go at this and you feel, oh yeah, I'm really secure with my whole numbers, I know what I'm doing here, I think you'll be able to have a go at the decimal ones because it works very much the same way. It's just applying all the place value that you've learned so far with your decimals. So have a little look at this and then have a go at the support task that we've put on there. There's a little challenge at the end that begins looking at decimals, but I think once you've done that, you'll be more than ready to try the main challenge. So here we go.
In today's lesson, we are comparing numbers up to 100,000. Here we've got two numbers, one created by Dexter, one created by Dora, using a place value grids. Tiny says Dexter's number is greater. He has used 10 counters, whereas Dora has only used 6. And if we counted up the counters, we'd see that Tiny is correct. Dexter has used 10, Dora has only put 6 on her place value grid. However, what each counter means depends on where it is on the grid. So on Dexter's grid, we've got 2 in the 10,000s column. That's 20,000. We've got 4 in the thousands column, 4,000. We've got 0 hundreds, we've got 110, and we've got 3 ones. So Dexter's number is 24,013. Let's have a look at Dora's number. Again, we'll start from the largest place value grid we have, the one furthest to the left, the 10,000s. Dora has got 4 in the 10,000s column. She's got 0 thousands, she's got 100, she's got 0 tens, and she has 1 1. Dora's number is 40,101. And if we were comparing those numbers, we could write a number sentence using an inequality sign. We could write that 24,013 is smaller than 40,101. How do we know that? Well, to compare two numbers, we start with the place value grid to the left, and because it's the same for both numbers, the 10,000s column, we can use that column. Dexter has 2 in the 10,000s column, Dora has 4 in the 10,000s column, so 20,000 and 40,000, and we know that 40,000 is greater than 20,000. We don't need to look at the rest of the number because we've started with the 10,000s column and we can compare using that column on the grid. So Tiny isn't correct. Let's think about comparing these two numbers A and B. We're going to work from the place value column on the left, which for both numbers is the 10,000s column. We can see the 10,000s column for each number is the same. We have 2 in the 10,000s column for A and B, so we've got 20,000. So in terms of comparing the two numbers, because they're the same, we can't use the 10,000s column, it doesn't help us. Does the thousands column help us? Again, we can see A has 2 in the thousands column, and so does B. So again, at the moment, the two numbers are equal to each other. We can't use the thousands column for a comparison. Let's have a look at the hundreds column. And the hundreds column is the first column that when we compare the two numbers is different. We have got 500 in number A, whereas we've only got 400 in number B. 5, only 4. So we know, because we've got more hundreds in A than B, that A is greater than B. The 10,000s column and the thousands column weren't useful, but the hundreds column was. We could, of course, keep going if we wanted to find out the actual numbers and look at the tens place and the ones place for each number, but we don't need to if all we're being asked to do is compare the numbers and say which is greater and which is smaller. How about comparing these two numbers? Well, if you show them on a place value grid, think back to what Tiny was thinking, we can see we've used far more counters to create number A than number B. However, let's do our comparison. And we can see we don't need to look at much at all, in fact, because we just look at the furthest left column here, and it's the 10,000s. And in fact, there is 0 10,000s in number A, whereas we've got 2 10,000s in number B. So there, we don't need to look any further now. We know that A is smaller than B. As well as comparing numbers, we sometimes have to order a set of numbers, and we've got 5 numbers here to order, starting with the smallest. How do we go about doing this? I'd first of all check that all the numbers we're dealing with are whole numbers, there's no decimals or fractions involved, and here we do have 5 whole numbers. So now we can start by looking at the number of digits. There's one number that's only 2 digits, so we know that that must be the smallest number because the other numbers have got more than 2 digits. So let's put 99 first, and I've crossed out 99 as you can see, so I can keep track of which numbers I've still got to deal with. Now we can see there's one number that's 3 digits, 513. The other numbers that we've not yet dealt with are greater than 3 digits, so we know 513 is next. Now we have two numbers which are 4 digits, those two numbers. We need to think back now to how we've been comparing numbers earlier in the lesson. We've got a 5 in the thousands column, we've got a 1 in the hundreds column, so those two columns don't help us deciding which is a greater and which is the smaller number out of these two. The tens column does, because we've got 0 tens in the number on the left and we've got 2 tens in the number on the right. So that shows that 5,109 is the smaller number. So we can put 5,109 there, and then we can put 5,122 there, greater than it. That leaves us with just one number, the 5-digit number, 11,022. So that will be the greatest number out of that set. Here we've got a comparison question, and I think we know that the large circle in the middle is for where the inequality sign goes, so greater than, less than, or equal to. But we've actually got two calculations here. So what we need to do is do the calculations first before we can do the comparison. These calculations you may be able to do mentally in your head. So the first one, the subtraction, is going to be 11,584. And let's do the addition as well. Well, that's going to be 11,584. So in fact, the inequality sign here is the equal sign. How about here? We've only got one calculation to do here, but it's probably a bit more of a tricky calculation. And I think a place value grid would really help us. So at the moment we've got 60,000. So we've got nothing in our place value grid apart from in the 10,000s. Let's just work left to right along the addition. Let's add 5, so that's 5 ones. And let's add 100. What number is now shown? 60,105. So we can see we're comparing it to 60,510. So that's the correct way around, isn't it? 60,510 is greater than 60,105.